Okay, now we're going to find the rate of change at a given point. All right, so it says find the slope of the curve at the given point P and an equation of the tangent line. So let's talk about the geometry for a second. If you're looking at something that looks like this, okay, so here's a circle, it's got some point P, and there's a line L that's being drawn tangent to the circle. What does tangent mean? That means it touches it only at one point. Okay, so it's only going to touch that curve at one point. All right, so if we look at this, okay, well, we only know one way to compute the slope. All right, and that's this formula. All right, so what we're going to do is we're going to make use of this version of the formula. Okay, so if I write down the average rate of change, all right, I'm going to use this formula right here, okay, to try to help figure this out. All right, so let's write down what we know about the function. All right, we know that y equal x squared plus 5x, and they want us to investigate the slope at the point 4, 36. Okay, so this is our x1 and this is our f of x1. All right, that's what we have right there. All right, so I'm going to write that down. x1 equals 4, f of x1 equals 36. Now, we're going to use that real generic formula, and that formula actually has a very special name, but let's see what we get. F of 4 plus h minus f of 4. Because if you see here, it says x1. Well, our x1 was over here, was 4. So, and x1 again comes back into place, so that's why I write just f of 4. And then I'm going to divide it all by h. Okay, so what is that? That is the difference between the two x values. If I have, suppose, some x2 value that I call 4 plus h, and I have some f of 4 plus h as some y value, for example, all right, then if I'm finding the differences between the h's, so 4 plus h minus 4, all right, so this right here is the x2 minus x1 component. Well, what's that? 4 plus h minus 4 is 4 plus h minus 4. The 4's cancel and we're left with h. Okay, so that's what that looks like right there. Okay, so h is what we're left with, and that's how we end up with h here in the bottom. So what we're going to do is we're going to plug in 4 plus h into x squared and into x right there. All right, it's not a big deal. Don't get scared. Okay, so what we're going to do is we're going to say, okay, well, that's 4 plus h squared plus 5 times 4 plus h minus 36, because that's 4. When you plug in 4 into the function, you get this right there, 36, all divided by h. Okay, so I'm going to make a side note over here, and I'm going to kind of zoom in just so I have a little more room. And I'm going to make a side note here for you. And let me see if I can change my pen color. Let's see here. How about this one? A binomial square, or binomial squares. All right, what does that look like? If you have something like this, a plus b squared, all right, you should have learned this in college algebra. You get a squared plus 2ab plus b squared. That's really important. And then the other version of this is a minus b squared, which is a squared minus 2ab plus b squared. So let's do a real quick example. If I have, suppose, x plus 5 squared, this is my a, this is my b, I'm going to square it, x squared plus 2 times, and then ab is x times 5 plus 5 squared. When I simplify all that, I end up with x squared plus 2 times 5 is 10 10x plus 25. It's a quick way to expand a binomial, the binomial square. It's a trick. It's a special product. Okay, so I'm going to zoom out now, and we're going to take a look at the product that we have here, which is 4 plus h squared. Okay, so I know we used x over here in the example, but it's not a big deal. All right, let me switch my pen real quick. Switching my pen. Okay, so I have 4 plus h squared. So if I square the first, I get 16. So that's 16 plus 2 times x, 2 times 4 times h is 8h, and then h squared. All right, plus, and then this part I just distribute, 20 plus 5h, okay, minus 36. Now, if you have a question about how I came up with this, okay, what I'm going to tell you, if you don't know the trick, is just use FOIL. All right, what do I mean by FOIL? All right, you're going to have to write it out as 4 plus h times 4 plus h. Okay, all right, so I'm going to erase this little mark here. That's all we're doing is FOIL, but I'm doing it in my head, and it's a neat trick to be able to use the binomial square. You're going to want to know the trick because this subject is going to get a lot more difficult. Okay, so keep that in mind. That's why we're doing it. All right, so let's try to combine like terms now. 16 plus 20 is 36. 36 minus 36 is 0. That's good. Okay, let's see here. 8h and 5h, that's 13h. So I'm going to have h squared plus 13h. Okay, and then what else do I have? Okay, divided by h. So you can divide out an h, all right? And when you do that, you end up with h plus 13. All right, well, what is h? H is some value of x units away from x1. But let's pretend, all right? So I'm going to say let's pretend h is so small that it's 0. Something really, really close to the number 4. Let's say it's 4.001. All right? What would you tell me the difference between this and 4 is? 0.001. Okay? It's something arbitrarily small. So if we pretend that we're really close to x equals 4, okay? So here's x equals 4 on the graph. We're getting really, really close in some direction because it could have been 3.999, right? We're so very close to 4 that this h here is negligible. All right? So we're going to estimate or approximate then that the slope of the tangent there, your slope, is 13. The rise over the run is 13. So this is the slope. All right? And I think that answers one question. Find the slope. Now, what we have to do is we're going to have to find the equation of the tangent line. So sometimes it's okay to leave it in point slope formula. Well, recall the point that we were using. It's way over here. All right? The point was 436. Okay? So if I have y minus 36, okay, that's going to equal 13 times x minus 4. And you'll find in calculus that it's actually acceptable to leave an answer in point slope formula, or in point slope form. But let's go ahead and simplify this. 13 times x is 13x, and 13 by 4 is 52. So y minus 36 equal 13x minus 52. I'm going to add 36 to both sides. What do I get? Y equal 13x, and then negative 52 plus 36 is negative 16. So this right here is the equation of the tangent line. Okay, equation of the tangent line. We have the slope and the equation of the tangent line. So let's pretend, I mean, maybe this is not necessarily the best graph or the best picture right here because the slope there is clearly negative. But imagine if it was positive and it's touching this circle, maybe right here. The line tangent would be right there. So this might represent that y equal 13x minus 16. And what we're going to talk about in this first part of a calculus course, which we call differential calculus, we're focused primarily on these slopes and equations of tangent lines. So as I tell my students, the strongest calculus student is the best algebra student. Notice a lot of the algebra skills, all of this was algebra, okay? The weakest student is the weakest algebra student. The weakest calculus student, weakest algebra student. So kind of keep this in mind as you go through. You might want to watch this video over again. And if this video was helpful, remember, as always, like and subscribe.